Hello friends, Mr. Burrell here. We're in the middle of Unit 5. We've talked about simplifying radicals, simplifying square and cube roots. That's what the first half of this unit has been about. This last half of the unit we're going to be talking about complex numbers, imaginary and complex numbers. I'm going to introduce what those are, and in this lesson we're going to talk about adding and subtracting complex numbers. So, by the end of this video, these are the things that hopefully you're going to be able to do. You're going to be able to reduce radicals containing complex numbers, add together complex numbers, and understand that adding and subtracting complex numbers is similar to how I add and subtract polynomials. So we'll get to each of these objectives in this lesson. So I want you to reflect back to the very first unit we had in the first trimester of Math 2. Remember talking about types of numbers? I had this big circle and I talked about a bunch of different kinds of numbers. I talked about natural numbers, I talked about whole numbers, I talked about integers, and I talked about rational numbers, and I talked about irrational numbers. I talked about a bunch of different kinds of numbers that were all considered real numbers. So we had numbers that could be written as fractions. I had negative numbers. I had decimals that never ended. Those kinds of numbers. All of those numbers were in one of these categories, and we called them real numbers. Well, this last lesson, when we were talking about square roots and we were talking about negatives, we talked about another kind of number that doesn't fit in this bubble, that doesn't fit in this spectrum. We talked about imaginary numbers. We talked about imaginary numbers and something we're going to talk about today called complex numbers. So outside of the real number spectrum, numbers that aren't real numbers I call imaginary numbers. Specifically, any time when I take the square root of a negative number. When I take the square root of a negative number, that gives me an imaginary number. Okay? So for example, in this last video, in the last lesson, when we were talking about square roots and we were talking about negatives, we determined that the square root of a negative 1 was equal to I representing an imaginary number. So when I square root something that's negative, it gives me something that's an imaginary number. So for example, just as a refresher, how would I go about simplifying these radicals? So like the square root of 36, for example, if I break down 36 into its prime factors, I get 3 times 2, 3 times 2, right? And when I write those in my number prison, 3 times 3 times 2 times 2, in a square root number prison, the numbers have to escape in pairs. Only one survives, and I'm left with 3 times 2, which is 6. The square root of 36 is 6. The square root of negative 36, I have the same prime factors, 3 times 3 times 2 times 2, and I also have a negative 1. 3 times 3 times 2 times 2 times by a negative 1 will give me negative 36. Well, still these 3's and these 2's have to escape. 3 times 2 is 6. And then this negative 1 that's underneath the square root escapes as an I, or as an imaginary number. So the square root of 36 is 6. The square root of negative 36 is 6I. When I break down the square root of 144, I end up getting 12. So the square root of negative 144 would be 12I. When I have a negative underneath the square root, the answer will have an I attached to it. So 12I, meaning that it's imaginary. So what about if I have an example like this, where I have the square root of a negative number with some variables? Let's see how that would look. So let's go ahead and look at like the square root of negative 150r cubed. So if I break down 150, I get 15 times 10 maybe, 5 times 2, 5 times 3. So if I wrote that underneath my square root, I'd have 5 times 5 times 3 times 2, 5, 5, 3, 2. I would have 3 r's being multiplied by each other, because that's r cubed. And then I'd have a negative 1, because this is negative. Okay? Well, these need to escape in pairs, so I have these 2 5's. I have these 2 r's. The 5 and the r are going to come out as 5r, which would leave the 3 times 2 and r to be left to multiply on the inside, which would be 6r. And then this negative 1, the square root of a negative 1 is an I, so that negative 1 would come out as an I. So this would be 5ri, or 5ir, you could write it either way, it doesn't matter, times the square root of 6r. So the big thing here is when I have a negative underneath the square root, that negative is going to come out of the square root as an I, as an imaginary number. Okay? So, for example, this would be an imaginary number, I. 7i would be an imaginary number, negative 2i, 17i, 114i. Anything with an I attached to it is an imaginary number. What about if I have a real number, like 4, added with an imaginary number? What is that going to be? Well, we're going to call that a complex number. So a complex number is an imaginary number added or subtracted by a real number. So when I have an imaginary number, something with an I, added or subtracted with a real number, like 3, for example, that would be a complex number. Okay? So we're introducing a whole new world of numbers here with imaginary and complex numbers. So now that we have that in our brains, we're going to take another step back. We're going to reflect back to Unit 2 when we talked about polynomials. So in Unit 2, we talked about adding or subtracting polynomials together. So for example, if here I have 3x minus 4 plus 4x plus 7, if I'm adding two polynomials together, I'm combining like terms. So I'm going to add my x's together, and then I'm going to add my real numbers together. So 3x plus 4x, well, that would be 7x. Negative 4 plus 7, that would give me a positive 3. So 3x minus 4 plus 4x plus 7 would be 7x plus 3. What about when I was subtracting polynomials? What was the difference there? Well, when I was subtracting polynomials, remember that I rewrote this second polynomial because there's a negative in front of it, and I changed all the signs. So this became a negative 10y and a positive 12. So then 5y minus 10y gave me negative 5y. 5y and negative 10y gave me negative 5y. And 8 plus 12 gave me 20. So I had negative 5y plus 20. Okay? So that was adding and subtracting polynomials. Hopefully we feel pretty comfortable with that. Well, what about if instead of a polynomial, instead of this x here, what if I replace that with an I? So instead of like a polynomial, I wrote it as an imaginary number, like 3i minus 4 plus 4i plus 7. So instead of writing two polynomials, 3x minus 4 and 4x plus 7, I wrote two complex numbers, 3i minus 4 and 4i plus 7. If I were to add both of those together, how would that work? What would that do? Well, I'm going to treat this I just like an x or a y. I'm going to treat it like a variable. So if I have 3 i's plus 4 i's, that's going to give me 7 i's. And then negative 4 plus 7 is going to give me a positive 3. See the similarities here? See what's going on? So down here, if I was to replace the y's with an I, 5i plus 8 minus 10i minus 12, again, if I were to replace that and write those numbers as complex numbers instead of polynomials, I would do the same thing. So I'd end up with negative 5i plus 20. Negative 5i plus 20. Okay? So, when I am adding together complex numbers, it's just like adding and subtracting together polynomials. I'm combining like terms. Combining my imaginary numbers together, so the ones with i's, and combining my real numbers together, the ones without i's. So, as a reminder, a complex number is an imaginary number added or subtracted by a real number. So I'm going to go ahead and practice a few of these adding and subtracting together. Let me move my face out of the way. So I plus I. 1i plus 1i. How many i's is that going to be? Well, that's going to be 2 i's. So I plus I is 2i. 3 plus 2i plus 4. Well, if I put my real numbers together, 3 plus 4 is 7, and then I have 2i. And you'll notice that most often when you write a complex number, people will write the real number first and the imaginary part second. It does not matter, but say they had a question like this on the ACT, the answer would probably be written this way, with the real number first, 7 plus 2i. What about negative 6 plus 4i plus 7 plus 3i? Well, I'm going to combine my real numbers together, negative 6 plus 7, which is 1. I'm going to combine my imaginary numbers together, 4i plus 3i, which is a plus 7i. So my answer would be 1 plus 7i. What about the subtraction problem? Well, that would give me minus 6 and plus 3i, because both of those signs would change. Then I'd have negative 8 plus 2i, minus 6 plus 3i. So if I combine my real numbers together, negative 8 minus 6 is negative 14. And a positive 2i and a positive 3i would give me a positive 5i. So my final answer would be negative 14 plus 5i. Okay? Let's try just a couple more so we can get used to what these look like. If I have 12 plus 3i minus negative 8 plus 4i, first of all, that minus is going to change each of these signs, so this turns into plus 8 minus 4i, and then I'd have 12 plus 3i over here. Again, I'm just combining like terms. These aren't polynomials anymore. They're now complex numbers, but the same principle applies. I'm going to combine my real numbers together, 12 plus 8, which is 20, and my imaginary numbers together, 3i minus 4i, which is a negative 1i, or negative I. So that would be my final answer, 20 minus I. If I had 9 minus 2i plus 6 minus 8i, again, I'd combine together, since this is an addition problem, my real numbers, 9 plus 16, which is 15. And then negative 2i and negative 8i would give me negative 10i. 15 minus 10i. And that would be my final answer. So you might be asking yourself, Mr. Burrell, what in the world, when would anyone need to know about complex and imaginary numbers? Where in the world does that even come into play? Who's going to use that? Well, here's just some examples of where we see complex numbers used in the real world. Electrical engineers deal with complex numbers actually a lot. Electrical engineers work a lot in the complex number spectrum. With like cellular and wireless technologies, they use complex numbers, stuff with complex numbers in radar. Quantum physics, some of you may not become quantum physicists, but they use that in quantum physics. And also we use it later in Math 2 and Math 3, so it is helpful and important to know. And there's other applications that I haven't specified here, but those are some of the areas where people use some of these concepts surrounding complex numbers. So that's it. That's the end of this lesson. Hopefully now you feel a little bit more comfortable reducing square roots that have imaginary numbers or complex numbers associated with them when you take the square root of a negative number. Hopefully you can add or subtract complex numbers together and recognize that adding or subtracting complex numbers is very similar to how we add and subtract polynomials. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.